Mass is an intrinsic property of a body. It was traditionally believed to be related to the quantity of matter in a body, until the discovery of the atom and particle physics. It was found that different atoms and different elementary particles, theoretically with the same amount of matter, have nonetheless different masses. Mass in modern physics has multiple definitions which are conceptually distinct, but physically equivalent. Mass can be experimentally defined as a measure of the body's inertia, meaning the resistance to acceleration, change of velocity, when a net force is applied. 1. The object's mass also determines the strength of its gravitational attraction to other bodies. The SI base unit of mass is the kilogram, kg. In physics, mass is not the same as weight, even though mass is often determined by measuring the object's weight using a spring scale, rather than balance scale comparing it directly with known masses. An object on the moon would weigh less than it does on Earth because of the lower gravity, but it would still have the same mass. This is because weight is a force, while mass is the property that, along with gravity, determines the strength of this force. In the standard model of physics, the mass of elementary particles is believed to be a result of their coupling with the Higgs boson in what is known as the Brout-Englert-Higgs mechanism. 2. Phenomena. There are several distinct phenomena that can be used to measure mass. Although some theorists have speculated that some of these phenomena could be independent of each other. 3. Current experiments have found no difference in results regardless of how it is measured. Inertial mass measures an object's resistance to being accelerated by a force, represented by the relationship F equals ma. Active gravitational mass determines the strength of the gravitational field generated by an object. Passive gravitational mass measures the gravitational force exerted on an object in a known gravitational field. The mass of an object determines its acceleration in the presence of an applied force. The inertia and the inertial mass describe this property of physical bodies at the qualitative and quantitative level respectively. According to Newton's second law of motion, if a body of fixed mass m is subjected to a single force F, its acceleration a is given by F/m. A body's mass also determines the degree to which it generates and is affected by a gravitational field. If a first body of mass ma is placed at a distance r, center of mass to center of mass, from a second body of mass mb, each body is subject to an attractive force Fg equals gmamb/r2, where g equals 6.67 times 10⁻11 nkg-2m2 is the universal gravitational constant. This is sometimes referred to as gravitational mass. Note 1. Repeated experiments since the 17th century have demonstrated that inertial and gravitational mass are identical. Since 1915, this observation has been incorporated a priori in the equivalence principle of general